through the question. So Matt's buying shirts for his company, okay, that prints shirts, art on shirts, and then he resells them. So as you know with companies, the more you buy, the cheaper that you can get the shirts. So he has his past 5 orders listed here. So what we're going to do is we're going to put these into our lists, okay, and we are going to be doing a linear regression so that we can find out some of the things that maybe Matt has bought a certain number and we want to check a price point, okay, or maybe we want to make a prediction as to what could happen if his shirts become really popular, his business explodes, and he might need like 10,000 shirts or something. Okay, that's what we can do with this type of equation. Okay, so the first thing you're going to want to do, so if you need to, go ahead and flip back to, okay, page 9. So step number 1, you need to clear your lists. Okay, so with your calculator, okay, if you do second plus 4, okay, that's the command to clear all your lists on your calculator. Okay, so when you click enter, it'll tell you done. Okay, then we can head over to the lists. Okay, so if you hit stat, edit, this is where you'll find your list 1 and list 2. So in looking at our question, okay, the X data, or the list 1 data, is going to be this first column, the number of shirts. Okay, and we're going to call this our X data. Okay, your list 2 is going to be your Y data. Okay, so go ahead and enter all the 5 numbers in your list 1 and your list 2. I'm going to do it with you. All right, so we have 500, 700, 200, 460, 740. Enter. Head over to list 2. 1.95, 520, 351, 169. Okay, so double check that both of your lists have the same number of numbers. If you like accidentally hit something, we had this yesterday, okay, where someone's list was a little bit bigger, so when they went to do the regression, it gave them a mismatch error. Okay, so if you have a mismatch error, just double check your lists. Okay, you guys are putting in your numbers? Awesome. Okay, then our next step, we want to do a linear regression. Okay, so you can hit second mode in order to exit the lists. Okay, so you're going to hit stat, and you're going to arrow over 1 to calc, and we're going to look for what regression type it tells us. So this one, it tells us that we're doing a linear regression. So that's number 4. Okay, so you hit number 4, and then you go through, you just hit enter until it goes through its menu, and then finally gives you a summary page like this. Yeah?
I'm not doing the R or R squared.
Oh, did you turn your diagnostic on yesterday? Okay, go to page 9. Okay, there's directions on, okay, doing the R squared one. You had to just do it once. Yeah, so second, 0, and then scroll to that. Oh, yeah, and then keep scrolling. It's alphabetical. Keep scrolling until you get down to diagnostic, yeah. Okay. Yeah. Okay, thanks for helping each other out. All right, so in your notes, we're going to write down this equation. Okay, determine a linear regression equation to the nearest hundredth. Okay, so guys, remember, this is where you're doing your summary, but we want to put all the decimals into our actual graph. Okay, so for this one, we're going to do the rounding. Okay, and then I'll walk you through the process of how we get all the decimal places into our y equals again. So here they've told us that it's a linear regression. So you can just kind of remind yourself that's the form for the linear regression. And then it wants it to the nearest hundredth. So take a look at your calculator. Okay, nearest hundredth is 2 decimal places. So you look at the second decimal place. You check the nosy neighbor next door to see if you're going to round. Okay, so we have a 6, so we're going to round up the 0.0065 to a 0.01. Okay. And then your B value is going to be 6.5. Okay, does everybody have the same equation? Okay, if your equation is a little different, it might mean that you made a typo when you were creating your lists. That's the only reason. That and whether you chose linear regression or a different type. Yeah. Oh, it might be. Let me check. Certainly is. Thanks. Okay, good catch. Okay, so now we're ready to put this equation into our y equals. So we're going to head over to hit your y equals, and don't forget to hit clear to just clear out anything that we were working on yesterday. Okay, now this is the one that you might want to write down in your margin. Okay, we're going to do vars. Okay, number 5, statistics. Vars. Okay, so these are your variables, and then you're going to do number 5, statistics. Okay, and then you're going to arrow over twice to the equation, the EQ. That stands for equation. And the first one on this list is your regression equation. Okay, did you find that? Yes. Okay, and then you hit enter. You guys are so excited about that. Okay, so it puts it into your y equals. Okay, we're almost ready to take a look. Okay, guys, what do we need to do before we hit graph? Okay, what might we want to change so that we can actually see something? Yeah, we want to change your windows. So, guys, go back to the question. Okay, your data will always give you an indication of what your windows should be. Okay, so one thing that I've noticed, okay, these are not in order. Okay, they don't have to be in order, but just make sure when you're taking a look at what your windows should be, that you're looking for the highest and the lowest. Okay, and then be like a little generous on each side. So for example, in this one, the highest looks like it's 740, and my lowest is 200. So I think if we did 100 to 800, we would see all of our data. Okay, so you could do something like that. Okay, you could set your window, okay, your X scale from 100 to 800, and you would see everything. Okay, how about the Y? What about the cost per shirt? We think a good range for that would be. On which part?
How'd you get the 1,000?
Oh, 100 and 800? So I'm looking here at the number of shirts. I'm just looking at the number of shirts, and I'm saying, what window would I be able to see all of these numbers in? Yeah, no, 100. So 200 was my lowest, and I went a little lower. Oakley, do you need glasses? Okay. All right, over here on our shirts, okay, it looks like the lowest number is $1.69. Okay, so why don't we go for, like, what do you think? $1? Sure. You could? Absolutely. Okay, so remember your window settings. There's no wrong window settings as long as you can see all the critical data. So if you choose a window setting that's a little different from mine or a little different from your elbow partner, okay, you're absolutely fine. Okay, as long as you can see all your stuff. So you could choose 0. Let's choose 0. And then, okay, the highest is $5.20. Okay, we could probably go to, what do you want? $6? 7? Let's go for 8. Like $8. Okay. So again, like you're just kind of trying to get a feel for it, because if you don't like your window, maybe you're not zoomed in enough and you want to see a little bit more detail, you just go back to your window setting and change it. Okay, so this is not a set in stone, this is pretty fluid. So let's head over and change our window settings. Okay, we said 100 to 800. And our Y values, we said $1 to 8. Okay, now you're ready to graph it. You should see a straight line, okay, on your window. Okay, you're seeing the straight line?
Yeah, I'm just.
Oh, you're setting the window.
Is it supposed to be negative 800 for
No,
this thing?
no, no. Because you're dealing with like actual numbers of shirts, so there's no negative numbers. Okay, looks beautiful.
800 and
Okay.
then.
So you go window, right?
Yeah,
You're gonna change this
Yeah.
one until 100,
yeah,
and that's it.
yeah, and then change your max to like something so that you can at least see your 700. So change it to 800. Okay, and then your Y, your smallest dollar, you could do like $0. Okay, and then maybe up to 10. There. Now you can see your graph. All right. Help a friend out. Yes.
Is there an easier way to do this? Because I had to just like scroll all the way down to 700.
Oh, yes, you can do it on your graph.
Oh,
Yeah, I'll show you.
okay.
Yeah. All right. Okay, we're seeing the graph. Okay. So once you have your graph, now we're ready to take a look at the questions. Okay, so it says here, Matt misplaced the information from the supplier about price discounts on bulk orders. He would like to get the price per shirt below $1.50. Hey guys, is $1.50 the X value or the Y value? The Y value. Okay, that's why we labeled, our columns so that we could come back to that. Okay, so when it talks about money, this is your Y value. So what it wants to know is, it says extrapolate the size of the order to determine how many shirts he needs to buy. So we don't have $1.50, okay, on our graph. It's below our graph. Okay, so that's, remember, extrapolation was when it's outside of the data that we have. Okay, so when we did this yesterday, when we have a Y value, go to your calculator and you hit Y equals, and we're going to enter that second Y value into the Y2 equals. So you're going to put the $1.50, okay, in your Y2 equals. Then when you graph it, you should have, okay, you should have 2 lines on your in your window. Yeah. Yeah, you might need to adjust your window if you can't see them.
What was the Y equals 150?
Yeah, $1.50. Yeah. Yeah. Okay. So remember, you have to see this intersection point in order for your calculator to give you the intersection. If you don't see the intersection, you need to adjust your windows until you can see it. Okay, then you're using second trace. Number 5 is intersect. Second trace, intersect. Yeah, and then it's going to ask you what's your first curve, what's your second curve, what's your guess. Okay, and you can just hit enter, enter, enter. Okay, it'll pull the curves that it sees in the window. Okay. Yeah. So what we're looking for is the X value. Okay, so let's write the X value down with 2 decimal places, and then we're going to revisit the question and see how to answer this. So 769.23. Okay, so when Y2 is equal to 150, our X value was 769.23. Okay, so guys, this is the number of shirts that he has to buy in order to hit $1.50 per shirt. However, when we talk about shirts, can we have a 0.23 of a shirt? No. Okay, how do we know whether we need to round up or round down? What do you think, Gareth? Okay. Okay. What do you think? Okay, guys. Let's hear what Cole's shared.
It's like the 10 place where it's like the 2 there. If it's above a 5 or above, and you round up. 5 or below.
Okay, that's how we typically round. I agree. Okay, do the rounding principles. Do we just round? Like, do we just not round because it's a 0.2, or do we maybe need to double check that it needs to be below $1.50? Okay. Yeah. Good.
Round down.
How do you know?
Because you can't like make more of a shirt.
Okay, so here's what I'm going to suggest, guys. Why don't we check both? Why don't we round down? And why don't we check the number 769 and see what our X value is? And then why don't we check the number, keep our X number, 769, see what our Y value is. And then why don't we round up and check 770? And then that way we can decide whether we should round down or round up. So this is what I'm talking about. So we're going to put in 769 and we're going to put in 770 because we're not sure. So we're going to use our reasoning in order to figure out which one is going to be accurate. So head over to your calculator, and if you hit second trace value, okay, it says, what X do you want me to check for you? Okay, so type in 769, enter, and it tells you that the Y value is 1.5015. Okay, so our Y value is 1.5015. Okay, guys, is this below $1.50? No. Okay, so let's check 770. Okay, so you can do second trace value is number 1. Type in 770. Okay, and now it tells you that your Y value is $1.49.5. 1.495. Okay, so in this instance, even though we're not using our normal rounding rules, okay, because this shirt, it needed to be a little bit more than 769 shirts. So we would have to round up to the 770 in order to get the price point that he wants. Okay, so let's sum it up like this. We can say, okay, if Matt wants below $1.50, okay, remember we're writing back what the question is asking. Okay, if Matt wants below $1.50, okay, we need to round up, okay, to the nearest shirt, which in this case is 770. Okay. So therefore, okay, Matt, okay, wants to know if he would like to get the price below $1.50, determine how many shirts he needs to buy. Matt needs to buy 770 shirts to get the price below $1.50. It is a whole lot of writing because this is an example. These types of questions are always going to be written response. Okay, so they want you to be able to do the math. They want you to be able to reason out, okay, how to interpret the data, and then you have to write a very beautiful, lovely sentence answer. Okay, always check if there's units involved. In this case, we have shirts and money. Okay. Before moving on, you might want to press y equals, and then clear, just so that you've cleared out the way for putting in our next question and our next equation. So I'm going to head over, I'm going to go y equals, I'm going to clear both lines, so I'm all set and ready. And then, okay, let's take a look at our next example. Okay, example number 3. Okay, we're going to do this one together, and then I'm going to have you guys try number 4, and then we'll check in, okay? So number 3 is talking about a world record for the men's 100-meter sprint. So in 1960, it was 10 seconds, 10.0 seconds. The table below shows the world record times since 1960. Okay, the wording here is very specific, and it's for a reason. Because the first point is 0. Because this is years after 1960. So guys, what would 1970 be if I was looking at it on the top here? If it's years after 1960, what would 1970 be? It wouldn't be 1970, it would be, how many years is 1970 after 1960? 10. Okay, so for example, it would translate to, if you saw, so 8, what does 8 translate into? 8 years after 1960 would be 1968. Okay, so that's how this graph is a little different from the other ones because you have a starting point. So you're going to have to remember to add the 1960 to whatever X value that we get when we pull it off. Okay, so let's go ahead and just remind ourselves that this is going to be our X values. This one's going to be your Y values. Okay. Head over to your calculators and you're going to do second plus 4 to clear your lists. Okay. And then you can hit stat, edit, there's your lists. Okay, they're all ready for you. So go ahead and enter the data. Zero, 8, 23, 31, 36, 39, 45, 48, 49. All right. Yeah. Okay. So part A says determine the equation of the linear regression. So we're still doing it linear regression. Once you have your lists in there, second mode to quit. Okay, and then we're going to do stat, arrow over 1 to calculate. And number 4 is our linear regression. Okay, enter through your things to let it calculate. And then you should have the values the same as mine. Okay. And we double check the question. The question says round to the nearest hundredth if necessary. Okay, so go ahead and round your A and your B values. Okay, so your A is negative again, and it's also 0.01. Okay, and our B value here is 10.03. Okay. Okay, if we're ready to see the graph, take a look at your data and see if you can determine the windows that you would choose. Okay. So your X values here go from 0 and they go to 50. So you want to be like generous. You might want to go a bit more than 50. Yeah.
Can I grab it? Do something there?
Let's take a look. Oh, so see how the time is like, it's really close to like 10, 9.9, 9.5 is the smallest number. So I wonder if in your window, instead of going from 0 to 15, what if we just went from like 11 to 9 and just made it smaller, and then that way you would see more detail. Okay.
But it's nothing. Like I messed around a little bit and nothing's showing up.
Oh, okay, let's go back to, so we have 0 to 55. Okay, if we're unsure if something went wrong, we can always go zoom 6, and that just resets it. And then we'll go back to our window, and you said 0 to, what did you?
55.
55. Okay, and then
I did 9 to 11.
9 to 11. Graph. Okay, oh, that's why.
Oh.
Your y equals is blank. All right, yeah, so check with your neighbor to help troubleshoot. Okay, guys, what have I not walked you through yet? So we can't see anything if we haven't put this regression equation into our y equals. Okay, so hit y equals, and then this is where you do vars, statistics, arrow over twice for the equation, and then the first one is your regression equation. Okay, we're going to get so good at this. Okay, my windows. Okay, I need to change them from last time. Okay, did you guys know that if you just hit zoom 6, that's like a reset to the 10, 10, 10. So if you're ever like you have no idea where to start, you can always go zoom 6 and just start from your origin and then make changes to your values. So if I look at my numbers, okay, my numbers go from 0 to 50, okay? So I might want to do, I don't know, I'm going to choose 0 to 75. Okay, I'm going to be quite generous on the other end just in case they ask me for like long-term plans. Okay, my time, notice how, okay, my time is like really close to 10 seconds and like the smallest is 9.58. So you don't want to go from like 0 to 20, otherwise it's going to look like a flat line. Okay, you want to like zoom in on your data, so you'd want to choose something a little bit above 10 and a little bit below 9.5. Okay, so someone said that they chose 9 and 11. Okay, that's a great place to start. Okay, we head over to our window, 0, 75. Okay, let's go from the minimum 9 to 11. Okay, so you should see a little bit of a slope. You should see a straight line on your screen. Okay, the ones that I'm seeing look good. Okay, so guys, what does our y-intercept represent in the context of this question? First of all, what is our y-intercept? Yeah.
Y-intercept is 10, and it represents the time at 1960, since that's 0 years after 1960.
There you go. Okay. Yeah. Okay, so I like that. So the y-intercept, okay, represents the time, okay, at 1960. Okay. So that's what your y-intercept represents. Okay, that initial moment. What was the initial time? Okay. So now it wants you to determine the world record in 2007. Okay, guys, can we, first of all, is our year, is that our X or our Y data? Our year. Yeah, it's going to be our X. Guys, can we type in X equals 2007? No, not on this question. Why not? Because of this thing right here, years after 1960. We have to do a little bit of a calculation first. Okay? We have to go 2007 subtract 1960. Okay? So when you do that, you should get 47. Okay, 47 will be in our window, and we'll be able to find that. So when it's the X value, when you go to your calculator, that's where you can do trace, and you can just type in 47. Okay, and then it will tell you the Y value. Okay, the Y value in this case was our time in seconds. So that means when we put in, okay, when we kind of translated the 2007, okay, we got, I just missed it, 9.72. Okay, it's reasonable to choose 2 decimal places because there's 2 decimal places in our data. Okay, so you want to reflect the numbers that they've given you, and so 2 decimal places is good. Okay, and then of course, sentence answer. Yes. Okay. What did you get? Yeah, so I'm wondering if there's something in your data. So just check your lists. So if you go to list, stat, edit, okay, just check your numbers over one more time, okay, and see if there's maybe, if it's looking okay, 9.5, 9.2, 6, 8, 4, 7, 9, 7, 7, 2, 5, 8. I don't know. Let me come back to that. Okay. All right. So our sentence answer here: the world record time. Let's finish this one up. Okay. In 2007. Okay. Remember to, in your answer the question that they're asking. Determine the world record time in 2007. The world record time in 2007 was 9.72 seconds. Okay, don't forget your units for that. Okay, and then what year did the sprinter drop below, the sprint speed drop below 9.89? Okay, 9.89, is that an X value or is that a Y value?
Y value.
It's a Y value. Yeah, so you're going to put that in for Y2 equals, and then you're going to do your point of intersection. Yeah, absolutely. Okay, well, let's take a look. Okay, so I'm going to do Y2, and that's going to be 9.89. Okay, we can do second trace. You're doing your intersect, first graph, second graph. Okay, and your guess. Okay, and so I see 21.47. Let's round it to 2 decimal places, 21.48. Okay, so when y is equal to 9.82, x was equal to 27.48. Okay, so this one, okay, if we, sorry, I wrote 27, and I was totally saying 21. Let me just double check. 21, there we go, 0.48. Okay.
Can you see how on the table that you're given is very unique? 23 years after 1960, the time is still higher than 9.89, right? But we're saying that in 1981.
1982, yeah.
Well, no.
We would round up in this one.
But see how at
Okay, so
23 years after, so 1983.
yeah, but we're trying to get 9 point. Oh, I see what you're saying. 9 point.
Should it be between 23 and 31?
9.89. It should be between here, yeah.
Yeah, but it's not.
Huh. I'll look into that.
was on a text. Did you go?
Yeah, it's my notes package. Okay. Yeah. So I have the same thing. I have 1960 plus the 22 years, okay, equals 1982. Okay. I did. No, because in 1981 it wasn't there yet. You had to like hit 1982 in order to get it. Again, we can do.
Oh, yeah.
Yeah. Yeah. Okay. So yeah. So these ones are okay. Interesting to take a look at. Okay. And again, if you're not sure whether to round up or down, okay, guys, just do a little check off to the side. Okay, do x is equal to 21, x is equal to 22. Okay, this is what I did. I didn't just decide, oh, on this case, let's just round up. Okay, no, I double checked. Okay, so when I went over to my graph and I said, okay, trace x is equal to 21. Okay, it was 9.893, which is not below. Okay, it's not below yet. Okay, 9.893. Okay. And then trace when I did 22. Okay, there we go. Now it drops below. Okay, so in this case, we had to round up to 22 in order to get it to drop below. Okay, actually, I have an answer for you, Cole. Okay, Cole was asking, like, well, the actual data. Okay, guys, here's the thing. Sometimes the actual data, like we're looking at the chart and saying, oh, I kind of expected my answer to be in a different range, right? Like when we looked at this, we kind of expected our answer to be greater than 23, okay? But we got the answer 22. So the reason for that is because a regression is like, remember it was that line of best fit. So some of the data comes above, some of the data comes below, and it tries its best to hit all of the data, but this is real life data being modeled by a mathematical equation. So it's pretty close, like it's not bad, but it's not always 100% accurate because there's always going to be outliers. Like maybe there was a new technology one year and Nike came out with this fabulous shoe that made everybody faster than other years. I don't know. Right? But that's why there's that little bit of a discrepancy because we have data and we're modeling it with an equation. Okay. So in this case, let me just finish with this, 0.886. Okay, so that's why we rounded to 22. Okay, if you're feeling good about this, I'm going to give you guys a few minutes to work on example 4. Okay, so to get ready for example 4, go ahead and head over to y equals, clear out your work so that it's all ready for you to put in your new equations. So one of the reasons, I'm just going to pause and give you guys a tip. Okay, here's your tip. Clear out the equation before you start the next question because sometimes we do the regression, but we haven't put it in yet. And when we hit graph, we're actually seeing our old information, okay, because we've simply just missed a step. So if you clear out your y equals, you'll never have the problem of accidentally seeing your old equation. Okay, and I think that's on page 9 of your notes as well. Okay, so I'm going to come around, check in, see how you guys are doing.